Dear students, today I will discuss about the analytic differentiability. What is analytic? Suppose for example, f of z is nothing but a function. Okay, is defined in a neighborhood. Let us take a neighborhood. Let us take a point z naught is a point which has a neighborhood. Okay, when f of z is said to be analytic means f of z should be analytic at a point z naught. Then we can say that f of z is analytic. If f of z is not analytic at z naught and remaining all means remaining all this in the neighborhood it is analytic except at z naught, then we can say that f of z is not analytic at z naught. Moreover, this z naught is nothing but called as a singular point. This is nothing but called as a singular point. Means if f of z is analytic at z naught, then we can say that in each and every neighborhood, if it is analytic, then we can say that f of z is analytic. But whenever except z naught, it is analytic in the neighborhood apart. This is all nothing but it is analytic in the every neighborhood of z naught. Then this z naught will be taken it as a singular point. Let us take one example of the singular point. This is singular point whenever it is not analytic at this one. Means analyticity is failed at z naught, but it is it is defined on each and every point in the neighborhood of z naught. Okay, so let us see the definition here. Suppose f of z is defined in a neighborhood of z naught, we say that f of z is analytic at z naught. If f of z exists throughout the neighborhood of z naught, f of z exists throughout neighborhood of z naught, we say that f of z is analytic in an open set. Means throughout the z naught is nothing but is called as an analytic function. And there is another definition is the differentiability here. We say that f of z are analytic in an open set S, it is differentiable throughout S. Means if a set if S is taken, so if it is analytic, then we can say it is differentiable. Otherwise, it's not differentiable. Or we may say that f of z is nothing but analytic on the set A. If f of z is differentiable on open set S, then it is differentiable which is containing a set A. Now, this is the definition of analytic differentiability. As just now I explained, the singular points of a complex function. What's the singular point? Just now I said, suppose f of z is complex function of f of z. F of z is a complex function. If f of z fails to be analytic at z naught, just now we are discussing about that. It is, let us say this is a neighborhood. Okay, neighborhood of z naught. Just now I said, if it is fail the analyticity function in this point, the point is nothing but z naught. If it is failed here, then we can say that this point is called as a singular point. Let us see. F of z fails to be analytic at z naught and is analytic at some point in every neighborhood of z naught except this point. It is analytic in every point of the neighborhood. Okay, it is failed only at z naught, then we can call it as a singular point. So let us see an example. Then we say that z naught is a singular point of f of z. Okay, now for example, if f of z is equal to 1 by z has only a singular point at z naught is equal to 0, means at z naught equal to 0, this is nothing but failing. One more example, f of z is nothing but z square by z square minus 3z plus 2. This can be written as z minus 1 and z minus 2. As you know already, z is equal to 1 and z is equal to, if you substitute z equal to 1, z equal to, this is nothing but failing. So 1 and 2 are nothing but a singular points. And one more example, f of z is nothing but mod z square has no singular points and z is equal to x plus I by, you know already, mod z square is nothing but x square plus y square. We already know that mod z is nothing but equal to root of x square plus y square. So therefore mod z square is nothing but equal to x square plus y square. So this is what we have. So therefore f of z is nothing but u plus iv and u is nothing but equal to x square plus y square, because this is the real part if we take, and v is nothing but if you take 0, means f of z is nothing but only real part you have, image part we don't have because there is no imaginary terms here. That's why we take x square plus y square and v is 0. and we differentiate this one with respect to x, you will get as 2x. Differentiate with respect to y, you will get 2y, and vx, these are 0. Now possibility is there, what? X has possibility at the origin,